My name is Giovanni Satoshi, and this is my 9-5 video problem for number 37. We have to find the sum of each infinite geometric series if it exists. So we are given n, the e over e, and then k equals 1. So that's the number of terms. And n represents the infinite. And then the explicit rule, which is 200 times 0.6 to the power of k minus 1. This is the explicit rule. Now 0.6 is the ratio because it's multiplied by 200. So since it's the ratio, we already identified r, or the value of r. Now 0.6 is less than 1, so we could circle it. And the reason why this is important is because it has its own sum formula. So since r is less than 1, we'll be using this sum formula instead of this one. That's only if r is greater than or equal to 1. This one is when r is less than 1. So we have Sn equals a1, which is the first term, over 1 minus r. So here a1 equals 200 because when you substitute all the a or k, n or k values with 1, so it's 200 times 0.6 to the power of 1 minus 1, which will become 0. Distribute that into 0.6, and the rule is any number to the power of 0 would always equal 1. So 200 times 1 equals 200, and that is our first term, or a equals 1 equals 200, or a1 equals 200. R, which is the ratio which we had discovered earlier, is 0.6, and n, which is the last term of the infinite series or sequence, remains as n. So when we use the sum formula earlier, we will get Sn equals 200 over 1 minus r. Now when you substitute r, you can put it in a parenthesis so that you can identify that it is r. Now by subtracting 0.6 from 1, we'll get positive 0.4, and when you divide 200 by 0.4, you get 500. So the sum of the infinite geometric series, which is this one, is 500.